Okay, so what we're going to go over today is adding and subtracting rational expressions. So, just like we did with multiplying and dividing, the first thing that we want to do is we want to factor out anything that we can on these to see if anything cancels out. So the first thing is to factor out the bottoms on these because the tops cannot be factored. I'm going to do the factoring fairly quickly here, but you can go back and review factoring if you need to review factoring. This one splits up into x and x. It's a positive 4, so we look in the middle. That tells me both of them will be plus, and the factors of 4 that give me 5 are 4 and 1. Then on the other one over here, we have 3x plus 3, so we can divide a 3 out of both of them, and again x plus 1 is left over. So let's go back in time just a little bit to something that you did a long time ago. You took things like 1/2 plus 3/4, and you learned to add those together. The only way that you could add those together by hand before the calculator came into play was using something called a common denominator, meaning you had to get both of these denominators to be the same. So now at this point, since you've done this a bunch of times, you probably know that you can just multiply this fraction here by 2 on the bottom and 2 on the top to make it be a 4, which is going to be a common denominator. 2 times 1 on the top is 2, 2 times 2 on the bottom is 4, and 2/4 is the same thing as 1/2. So then you added 2/4 plus 3/4 to get 5/4. Notice that the bottom did not change. We're going to use the same concept over here, but you've got to actually go back a little bit to before you just knew how to do this in your head and figure it out. If you go back and look up here, 4 is actually 2 times 2. And so this fraction here had a 2 in it. This fraction here had 2 2's in it, or 2 squared. So that's why you had to multiply by this other 2 to get it to be the same as this one. So we're going to use the same concept down on the other one. Notice that this one here has an x plus 4 and an x plus 1, right here and right here. This one has a 3, and this one also has an x plus 1. So they both have an x plus 1. But this one has an x plus 4, this one doesn't. This one has a 3, this one doesn't. So what you want to do is get them to both have the same thing. So look at the one on the left. It has an x plus 4 and an x plus 1. What does this one not have that this one does have? This one has a 3, this one does not. So we're going to multiply by a 3 on the top and a 3 on the bottom to get it to be a 3 just like the other denominator has. Now go to the one on the right. The one on the right has a 3 and an x plus 1, but what does it not have that this one does have? It does not have an x plus 4. So we multiply by an x plus 4 to get it to be the same on both denominators. So then you just treat it like you did the numbers. 3 times 1 is 3. Then you have your denominator 3 times x plus 4 times x plus 1. Technically, you could multiply those together, but it's okay if you just leave it just like it is. Then on the other one, we do the same thing. We multiply 5x times x plus 4. That's going to be 5x squared. 5x times 4 is 20x. The reason I'm actually multiplying those together is because I am going to have to do my adding step here in a second. And then on the bottom you have 3 times x plus 4 times x plus 1. Notice I wrote that in order just so it looks like the other one, so you can see that it's a common denominator. Then you add the tops together. You have 5x squared plus 20x plus 3. Notice there are no like terms in this one, so this one's really easy. If there are like terms, you just add the like terms together. Now you have just added these two rational expressions together. So here's one for you to try. Pause the video and try it on your own. Then I'm going to go through it. So again, we factor out the bottom on this guy. X and x, it's a negative 12, so I put plus and minus. The factors of 12, 1 and 12, 2 and 6, 3 and 4. 2 and 6, if I use a positive 2 and a negative 6, are going to give me the negative 4. Then I have 3x on the top. 4 factors out, and then x plus 2 is left over. So notice again that this one has a 4, this one does not. So I'm going to multiply by 4 on top and on the bottom. This one has an x plus 2 and a 4, but it does not have the x minus 6. So we multiply by x minus 6 on the top and on the bottom. On the top of this one, 4 times 1 is 4. And then you have your denominator all combined together. On the top of this one, 3x times x is 3x squared. 3x times negative 6 is negative 18x. And then you have your denominator all together at the bottom. If you add the tops together, there's nothing really, again, to add on this one. No like terms. But I'm assuming that you understand how to add like terms together by now. And your denominator doesn't change because it's the common denominator. And that's what we do with common denominators when we add them together. So now we're going to take a look at subtraction. With subtraction, one possibility is to just look at it and say, okay, I do the exact same thing we just did, except there's a minus in the middle, and I just remember to subtract at the very last step once I get my common denominators here, and just subtract. The other option, which is the option that I prefer, and the option that I'm going to show you, is to take it and change it to addition, meaning leave, change to addition, change to negative 4. Notice I didn't change the bottom, because if you change both of these, that would be a negative divided by a negative, and that would be positive. You change the whole problem and mess it up. So I don't change the whole function, the whole fraction over here. I just change the top to a negative because that makes the whole thing negative like it used to be. So leave, change, change. Now it's just back to an addition problem. If you want to go ahead and pause the video and try it again, that's fine. I'm going to go ahead and go over it as well. So 7x is on top over here. I can divide a 5 out of both of these and get x squared minus 5. 25, sorry. That was definitely not the computer's fault. That was the ID10T error there. Over here, you can also split up x squared minus 25 into x plus 5 and x minus 5. On the top of this one, negative 4. On the bottom, you can divide out 3 and get x plus 5. So now we do exactly like we did before. We look at both denominators and we see what they have and see what they're missing compared to each other. If you look at the first one, it's got a 5, an x plus 5, and an x minus 5. but it doesn't have a 3. So we multiply by 3 on the top and the bottom. You look at the second one. It's got a 3, it's got an x plus 5, but it doesn't have a 5, and it doesn't have an x minus 5. So you're going to have to multiply it by a 5 and an x minus 5 on the top and on the bottom. And that side's going to be a little trickier. On the left one, 3 times 7x is 21x. 3 times 5 is 15, so that's just 15 and x plus 5 and x minus 5. On this one, you are going to have to be a little careful at the top, so let's start with the bottom first. 3 times 5 is 15, and then you have your x plus 5 and your x minus 5. And guys, remember, the reason I can do that is just because all of these are multiplying by each other. So that gives me a little clue of what I need to do at the top as well. It's negative 4 times this, so I can actually multiply negative 4 times negative 5 first, then distribute it. So that would actually be negative 20 times x minus 5. Negative 20 times x is negative 20x. Negative 20 times negative 5 is positive 100. Now I can collect my like terms across the top because my denominators are the same. So what is 21x minus 20x? 1x. And then you have your plus 100. And your common denominator stays the same on the bottom. So that is adding and subtracting rational expressions.